What happened, Monica? What happened, Monica? Tell me. Which question you are confused? So I am coming. Okay, answers are coming. Yes, that will be decomposition will be lossless. Why? First of all, you have to check that R was A, B, C, D, E. Now they are divided into two parts, that is R1 and R2. So here A, B, C and here it is C, D, E. Right? They are divided into two parts. Now I have to check what is the common. R1 intersection R2 implies R1 minus R2, or R1 intersection R2 implies R2 minus R1. That is here. Now I have to say that yes, what is possible. So from here I have to check C implies AB or C implies DE. Any one them is satisfied or not. You have to check this C. In the C there is no duplicate. There is no repeating element. As there is no repeating element, so definitely C can determine A also, B also, and C can determine D also and E also. No problem is here. That's why it will be lossless. That's why the decomposition will be lossless. These are the types of question. Indirect question. Directly you know whenever dependency is given. If the dependency is not given, then how to do? This is the way you have to do if the dependency is not given to you. Okay? Clear? Is that clear? Yes. Are you okay? Are you okay, all of you? Can we go ahead? Can we go ahead? Are you okay? Okay. We can go ahead. Okay. Then chalo. So in ER diagram, whenever you are coming to the ER diagram topic, what is there in ER diagram? In ER diagram topic is entity relationship diagram. ER diagram in the database, there is entity, these are the weak entity, attribute, these are the key composite attribute, multi-valued attribute, relationship, one to one, one to many, many to one, many to many. These are the attributes are here, right? Yes. So here whenever these are possible, then how to do? Here this chart is very important chart. How to represent, what is the diagrammatic representation, the images, entity set, this is entity set, relationship, this is relationship, weak entity, what is weak entity? Who don't have primary key, it is dependent on any other any other table. It is dependent on any other entity. Okay. So thank you Sharma. Weak relationship, when a weak entity is making the relationship with another entity, that is called weak relationship. Attribute we are representing like this way. composite attribute. What is the combination of multiple attribute? That is called composite attribute. So composite attribute means here we can combine that is last name and first name. First name and last name you are taking, you can combine. Or address, you can take the city, state, street number separately, then you can combine. That is the example of composite attribute. Multi-valued attribute. What is multi-valued attribute? Phone number. Phone number, nowadays everyone have at least two phone number. At least two phone number everyone have. So that's why this is the multi-valued attribute. Derived attribute. Derived attribute means, and whenever there will be a multi-valued attribute in a ER diagram, then definitely you have to create a separate table. A separate table is required for a multi-valued attribute. Derived attribute, age. From the date of birth you are deriving the age. That is the derived attribute. Key attribute, that is your primary key. What is your key? Through the key you are identifying, that is called the key attribute. Partial key means when you are combiningly mapping the key with the two attribute, then part of that is called the partial key. Other than that, there are some key constraints: total participation, 1 to 1, 1 to many, many to 1. These are the participation. How to do the participation and cardinality? I am coming to you. Do this one. Tell me what will be the answer. Then I am coming to cardinality and participation. Do this one. I am coming with my water. Do this one. I am coming. Okay, answer came from everyone. Yes, this is your answer definitely. Where this is your weak entity, this is the multi-valued attribute, and this is the key constraint. Here this is the key attribute, and here this is the total participation. So how the total participation and cardinality I am coming here. Participation means minimum number of relation of an entity can participate. Minimum means one employee can work for one department minimum, and in one department there can be 0 employee also. Maybe it is a new department and there is no employee. That's why participation can be 0. When the participation is at least 1, means minimum is at least 1, that is called total participation, and we are representing the total participation with double line. This double line is the meaning of total participation, means minimum at least 1 participation is there. What is the meaning of cardinality? Cardinality means what is the maximum number of relation that one employee can work for one department only. That's why maximum is also 1. But one department there can be many employee. Multiple employee can be there in a one department. That is called the cardinality. And that's why here cardinality will be, this one is M. So cardinality is the maximum, participation is the minimum. And with here you can go for the key constraint. You can see the key constraint here. The key constraint meaning is here the cardinality 1. Meaning is cardinality 1. And whenever you are drawing any relationship, at the time of drawing relationship, be careful here. As here was the employee and here is the department. Okay. So employee is here, department is here. The relationship is coming with cardinality always, not with the participation. Always it will come with cardinality, not with the participation. So here the cardinality was 1 because one employee can work for one department only, that is 1. In one department there can be multiple employee, that is M, right? So that's why what is possible, 1 will go in this side and M will come in this side. That will be now M is to 1. It is very important. Don't do this mistake. Always remember 1 is going this side and M is coming this side. That's why the relation is M is to 1. Don't tell that key relation is 1 is to M. If you are writing 1 is to M, that is wrong. Don't do that. Okay. So this is the meaning of this one. And how to get the one key, where is the key constant? If it is given like that, this is here. That is the meaning. Here the cardinality 1. The meaning of this key constant is, in the employee part cardinality is 1. That is the meaning. Now sometimes questions are coming on that how many tables are required. How many minimum number of tables are required for the diagram. This type of questions are coming in your diagram. So for that I am telling you one trick. That is when the relation is 1-to-1 relationship. The relationship is 1-to-1. Then there will be, for this one table will be required, for this one another table will be required, and this relationship table you can combine with any one of them, because here is also cardinality 1, here is also cardinality 1. Either you can do T1 R1 also, or you can do T1 R2 also, or T2 R also. There is only one relation. So either you can do T1 R or you can do T2 R. Means relationship you can add with anyone. If it is one to many, relationship, then what you can do? In one to many relationship, this is actually the one part and this is actually the many part. Always remember, you can add the relationship with the table where cardinality is 1. That is only you can add. You can add with the where cardinality is 1 with that one. So if this is my employee table and this is my department table and this is the relation, so the relationship can be added with the employee table only, not with the department table. Don't do the mistake here. Okay, for many to one also same thing. If it is many to one, then also same thing. With the cardinality one part only you can add the relationship, otherwise not. But if it is a many to many relationship, many to many means both part are here, this is the many to many relationship, then what will be happen? For many to many relationship you have to create a new table. There it is required 3 table. Here it is required only 2 table, here also 2 table, here also 2 table, but here it is required 3 table, because as this one is many to many relationship you have to make separately. You cannot combine the relationship. It will be not able to possible to combine the relationship. Ma'am, why? You can ask me why. Because just think an example, employee department. Okay, think that example. Here many employee can work in one department, many department can have one employee. Now the relationship in the employee table, can I add like that employee ID and here is department ID? Can I do like that? Ki employee 1 is working in department 1, employee 1, 1, 2, 3 like that way. That one employee is working in multiple department, because multi-valued attribute is not allowed. Here also can I do like that? Ki this is the department table. Here is the DID. Here is the EID. Department 1, employee E1, E2, E3. Can I do like that? That is also not possible, because it is coming multi-valued. So that's why what I have to do, I have to create a separate table where I will do EID and DID. Employee 1 in department 1, employee 1 in department 2, employee 1 in department 3. Like this way I can create. That's why here the extra thing is required, that is the extra table is required. Otherwise you cannot do it. Is that clear? This is the main concept of ER diagram. But here whenever you are taking that ki okay, this is the employee table and this is the department table. In the employee table cardinality is 1, department table cardinality is M, means this is the relationship many to 1. Then what will be happen? With the employee table, when there is EID 1, name is A, and then I can add DID, because one employee maximum one department, that is D1. Employee 2B, it's working in department 2. Employee 3C may be working in department 1. That is possible. That is possible. Because here is the cardinality 1. Here is the no chance that one employee will work for multiple department. Whenever one employee is working for multiple department, then there will be the multi-valued. Multi-valued will be not possible. Can I add here? Here I cannot add, because in the department there is DID, it is the department name, and here is the EID. In one department there will be maybe employee 1, employee 2, employee 3. I cannot do that, because here it is many. One department can have many employee. As one department can have many employee, I cannot do it. I cannot add it. That is the reason when it is one to many or many to one, always remember you can add the relationship where cardinality is 1. Here many to 1 means cardinality is 1 here. That's why you can add in the employee table. Clear? I hope it is clear to everyone. Total participation, partial participation, everything is clear? Yes. Achha, tell me what will be the answer for this one. Quickly do this. Yes. So given ER diagram and relationship model, which one is incorrect here? That is, this one is incorrect, because in row of a algebra relation there will be more than one attribute. That is not possible. More than one value means multiple value. That is not possible. Now tell me what will be the answer for this one. Yes, here the answer will be D, because relational database schema represent the logical design of the database. That is correct, but current snapshot is taking only degree not, it will take the cardinality also. That is number of data. It is focusing on the number of data. That is the cardinality. It is given only degree, that is number of attribute. That's why this is wrong. Now tell me what will be the answer for this one. I am going on only. Yes, so what is the answer here? 4. Because degree of a table R, degree means number of attribute. Here whenever you are taking, there is the 3 attribute here. Here also there are 3 attributes. You are combining them. You are doing the cross product. So total 3 plus 3 will be 6 here. Cardinality means number of row. So here was 3 and 5. So it will be 3 multiply 5, that is 15. Cartesian product. After Cartesian product, it will be 15 here. Foreign key of the relationship table. What is the foreign key here? Foreign key will be for the student table foreign key. You can see in the student table roll number, name, course number. Here this course number is the primary key, this is the foreign key. So that's why definitely this is my foreign key. For the course table there is no foreign key. So that's why it is the answer. Yes. Achha, now I am asking you another question, that is a good question. Tell me this one. Number of table required and what are the table here? What is the minimum number of table required here? And what will be the attributes in the table? What will be the attributes in the table? That is also you have to tell me. Okay, thank you. Thank you. Do your best in your NIC exam also. Oh, it is coming on 12th December. NIC exam. Do your best. How many table will be required and what will be the attributes? Okay, Monica, I will also end. I will also end because we have 6:30 class. So I have to also end. Yes, the 5 table will be required here because here is the key constant. These are the key constant here, right? So these are the key constant here. Whenever these are the key constant, then you can combine R1, R5 and R4 with this. So that's why these all are combined. And here what are the attributes are possible? B1, B2, A1, C1, D1. All are possible. Now you can see here also the key constant. This is also the key constant. So that's why it is the cardinality part. So I can combine the R3 with this table. After combining I can get this one. But this one is separate. So that's why for separate table I have to make. Here this is many to one, many. Because here there is no key constant, means it is many to many. In the many to many I have to make a separate table R2, and here I have to take the candidate key of this one and this is the primary key of this one, that is A1 C1. And here this table is separate. So this is table 1, table 2, table 3, table 4 and table 5. These are the all tables are possible here. This is table 1, table 2, table 3, table 4 and table 5. Okay, these are the all tables are possible. Okay, in this way we have to, you can do it. Tell me this one. After ER diagram I have to end because otherwise I cannot talk in 6:30 class. I have a paid course on 6:30 PM and there I promise that we will do the compiler PYQs, compiler expected MCQ and PYQs. All MCQ we will do today. That is my promise. So I have to keep my promise also. So after this CR diagram and more than that I will be not able to possible. Other topic You are asking about B3, B plus T. It is there, already there. What is not there that much, that I cover. Okay, so B3, B plus 3 topic, SQL, transaction, these are the recently I cover this all the topic, and that is there. I will show you where it is possible. I am showing you, you can definitely go through it. So here it is 3 table, because 1 too many, for that there will be 2 table, but a multi-valued attribute is there. As there is a multi-valued attribute, so that's why you can go for 3. Here it is 1 extra required. Yes. Now tell me how many table will be required here. How many table will be required here? Tell me tomorrow what you need. Tell me tomorrow what you need. I am planning like that way. Whatever is not available, where more thing is required, that is I am, and what is more important for your exam, where this time exam question can come, that is I am focusing. According to my prediction, this year DBMS will be more focus. DBMS, computer architecture, yesterday we covered those topic, computer architecture plus operating system. DBMS also we cover, and another topic is DS algo, can be more question. Software engineering, so many classes are there, don't ask me more. So many software engineering classes are already there, and I took very clearly this year only I completed. Although these are also present, but in DBMS recently I was not taking that much class, that's why I arrange. Yes, here also 3 table will be required. Because why? Because you can see this is the key constant, this is also key constant. This key constant is attached with this one, and this key constant is attached with this one. That's why here your table will be M table. You have to combine M1, M2 with M3 with P1, because in this M table this P1 will be added, and P table P1 P2 separate. In the N table you can take the P1, because of this key constant is here in the N table. So N table will be like this. Okay, yes, so that's why it will be your answer. That's why it will be your answer, right? Okay. Okay, Debolina bankers algorithm we cover in the paid course. Those who are there in the paid course, you are not coming to the paid course, you are doing blunder mistake. I am covering so many things in the paid course. Bankers algorithm we did. Please watch that. I think you are there in paid course, right? If you are there, then try to utilize. Okay, yes, so here this is the 3 table. Now this is the last question on ER diagram. Do this one. After that I will show you the remaining topic from where you can cover, that are also important, and quality classes are already there. I know that. I am showing you. More than that, time is not there, and I have to also take little bit rest to continue the 6:30 class again. Tell me what will be the answer for this one. Tomorrow either we can do TSC, or we can do DS algo, or we can do AI also. AI revision also we can do. So whatever your choice. Tomorrow is 3rd. 4th and 5th we have to do throughout the syllabus some question. nothing, definitely Devolina, definitely, yes. Okay, so here what will be the answer? Consider the ER diagram model E1 and E2 connected with M1 and Mn. Here draw this one. That is, you can see here Mn relationship. E1 E2 connected with M1 Mn, right? So here you can see this is M is to N relationship. Here is E1, here is E2, E1 E3, and E1 and E3 is connected with 1 into 1 is to many. So here is another relationship. With that relationship E3 is connected, and this is 1 is to many relationship. Okay, and here E1 is two single valued attribute, these are given, and E3 this is also given. Then the relationship not have any attribute, that is also given. If the relational model derived from the ER diagram, then the minimum number of relation required. What will be the minimum number of relation? From here, as this is 1 is to many, I can combine them as a relation. So from here 2 relation is required, and from here it is already common. From here how many relation? For this many to 1 I need another 1 extra, right? And this is 1 extra. So that's why total will be definitely 4. Definitely 4 will be my answer, because here I need 1 table, for this one I need 1 table, and for this 1 to many part I need 2 table. So 1 plus 1 plus 2, that is 4. To confuse you, they make it 3NF. It will be definitely in 3NF, because here are the attributes given. You can see everywhere there are 2 attributes. There will be no chance of non-prime to non-prime. There will be no chance. One will be the prime attribute, another will be the non-prime attribute. No chance of non-prime to non-prime. So definitely answer will be 4. They are making this type of stories to make you confuse. Read the story and draw the diagram and come to the solution. That is the simple one. Read the story, draw the diagram, come to the conclusion. Don't be confused. There will be no chance, because only 2 attributes are present. Whenever there is 2 attribute, then it will be definitely in BCNF actually. It will be definitely in BCNF, because one will be your candidate key, another one will be your non-prime attribute. Right, so definitely it will be in BCNF for 2 attribute, and here there is no chance. So that's why this answer will be 4. Is that clear? Clear to everyone? So I hope you understand everything about ER diagram, and your mind mapping about this subject is done. I tried to cover those subjects where you can get comprehension type question, and other topic already present here. Go to our channel Unify Study, go to here, search the name Unify Study here, Unify Study, search this name and come here. Here you can come to this channel, and after that you can see this 45 days crash course. Already more than 90 sessions are there. All the sessions as per your requirement, whatever sessions you need, whatever topic you need, as per your requirement, all the topic are here present. For DBMS, if you scroll down, then you can see the DBMS topic here. These are the all topic in DBMS. Normalization, functional dependency, serializability. This is the transaction topic. Serializability, transaction and concurrency, PYQs and SQL. This is the SQL question. Okay, here is the SQL. These are the topics are available to you. And other than that, B tree, B plus tree is here. AVL tree, B tree, B plus tree is here. So just visit this. You can see everything is present for you. And definitely visit our app also, Unify Study. Go to our website, visit it. You can come to the free mock test. So many free mock test of computer science is available for you. These are the all free mock tests are available for you. For the database, go to the database and attempt that mock test. The mock tests are available. And other than that, definitely you can utilize other mock test also. Okay. And if you are interested, you can join our paid course from here. These are the paid course. That is the recorded version will be available, because on 5th I am going to end it. Later again we will start new batch. So when you are watching, according to that it will be. Go to Google Play Store and install the app and rate and review this app. Unify Study, if you are giving rating, review, and if you are installing this app more, you are using that app more, then it will be helpful for Unify Study. Okay. Thank you everyone. Please like, share, subscribe and stay tuned with Unify Study. Utilize as much as possible. We are trying to put our 100% for you, and I hope you can also put your 100%. Right? Okay. Thank you everyone. Bye. Those what are the topic was in detail required, I provide it, and this class I will add in this course also, because here some missing thing was there that I have covered. So I hope after that there will be no doubt. Bye everyone. See you again tomorrow. And tomorrow, as you all are telling that key what you have to do, you all are asking about most of the AI, TOC, AI, DS algo. So we can do one thing, the all important algorithm revision we can do. It is AI also, DS algo also. All important algorithm related, data structure algorithm and related to normal algorithm and the AI algorithm also. Tomorrow will be the mind mapping of algorithm, what is related to your AI and what is related to your normal subject of data structure algorithm. So tomorrow this way our mind mapping will be done. Okay. All algorithm throughout our subject, what are the all algorithm, list of all the algorithms one by one we will revise the main points and complexities, and we will practice some questions so that all algorithm will be covered. Okay, that will be better, and I hope you will get the question from that area. Algorithm day we will dedicate tomorrow for algorithm day. ठीक है, all the algorithm we will dedicate. चलो, bye everyone, bye. We will meet again 6:30. Paid learners, 6:30 class will be there for compiler, expected question, all MCQ we will practice. 3 PM only tomorrow we will come, and 6:30 PM as we know MCQ practice is going on. I am